Hello there, my name is Sophia and I've created PulsePlay. So, what's PulsePlay? PulsePlay is a platform integrated with Spotify to allow Spotify users to generate a playlist that matches their mood using machine learning. There are several problems that have led to the development of this project. The first problem is generalized music recommendations. Music streaming apps like Spotify and Apple Music have their music recommendations. For example, Spotify offers playlists for different moods such as sad, romance, and happy. However, the songs are catered to the public's music preferences, so it may not match an individual's taste. In the Spotify app, in the search tab, you can find a mood genre, and then they will give you multiple suggestions depending on the category. The first one is sad mood. And as you can see, the suggestions are fairly known to public music. However, this does not match my likings. This is another example of playlists that are catered to the public's music taste. And for this playlist, I have not listened to any of these songs, so they may not match my music taste. And this playlist, similar to the previous one, it matches the public's music taste. And again, this playlist contains songs that are liked by most people but not necessarily everyone. The second problem is bottled up emotions can cause harm to health. This statement is supported by the article Music, Mental Health and Immunity, where it states that bottled up emotions are harmful and music can be a way to express emotions. It also says that music can alter the stress level by affecting the heart rate, respiration, and other autonomic system. In another article, How Music Can Make Us Feel Good, it says that music can trigger brain to release dopamine when the person listens to their favorite music. The third problem is that creating a playlist specifically for the current emotion can be a distraction. When a user does not enjoy the playlists that have been suggested by Spotify, they may start creating their own. So, while the user is choosing the songs for the playlist, they will unintentionally distract themselves. This will leave the emotions unattended, which can be harmful in the long run. Moving on to the objective of this system, the first one is to compare four machine learning algorithms' performance on song prediction based on mood and music taste. The second objective is to provide an emotionally tailored and personalized song playlist using a machine learning model. And the third one is to enhance mental well-being by providing a seamless experience with Spotify. Now, I would like to highlight the intelligent computing component, which is machine learning. Machine learning is used in Module 1, where four algorithms, which are SVM, KNN, logistic regression, and decision tree, are trained and their performance on predicting the song's mood are compared. From the comparison, decision tree performs the best in predicting the song's mood, so it is implemented in the Module 2, where decision tree is implemented using Joplib. This is the module diagram of the system. There are four modules. The first one is algorithm comparison, where it built and trained four machine learning models, compare the performance of each model, and lastly, it will be implemented in PulsePlay. And the second module is generate personalized and mood-tailored playlists, where it will accept mood from the user input, retrieve users' listening history, top tracks and saved tracks from the user's Spotify account, and then it will perform prediction of the song's mood. Lastly, it will generate a mood-based playlist according to the music preferences. Next is feedback. It gets the feedback on two things. The first one is the accuracy of the song's prediction, and the second one is how the playlist has affected their emotion. Lastly is the user authentication module, where user will authorize PulsePlay to access their Spotify account. This is the result of the Module 1 comparison. For Module 1, each model's accuracy is high and decision tree scored the highest with 90.7% accuracy. However, since the dataset used for training is large, the SVM model is trained with a subset instead. Now is the project implementation. This is how the machine learning model is implemented. For the input, it will be the user's Spotify data, which are listening history, top tracks, and saved tracks. The songs retrieved will have their audio features extracted from a dataset. These audio features are the features that will be used by the decision tree model to perform the prediction on the song's mood. The first feature is acousticness, where the value ranges from 0 to 1, where 1 represents high confidence the track is acoustic. The second feature is danceability. It is the suitability of a track for dancing. The third one is the duration of the track in milliseconds. The fourth one is energy, where it measures the intensity and activity of the song. The energy value ranges from 0 to 1, where values closer to 1 are songs that feel fast, loud, and noisy, such as Animals by Maroon 5. Slower songs like I'm With You by Avril Lavigne will have lower energy value, which are closer to 0. Next is the instrumentalness. It is the vocals in a song. The instrumentalness value range from 0 to 1 as well, where the values closer to 1 are most likely to have no vocal contents, meaning that there are little to no lyrics in the song. The next feature is liveness. It is the presence of audience in the track. This means that this feature determines whether this song is performed live or not. And next one is the loudness. It is the overall loudness of a track in decibels. Next is the speechiness. It is the presence of spoken words in track. Tracks with higher than 0.66 value of speechiness are probably made entirely of spoken words such as talk show or audiobook. Songs usually will have speechiness value between 0.33 to 0.66, like the songs that we usually listen to on the radio. Next is the tempo. It is the speed or pace of a track in beats per minute. And the second last feature is valence. Valence is the musical positiveness in a track. The valence value will range from 0 until 1, where songs with valence value of closer to 1 are likely to be positive songs such as happy songs or energetic songs. And the last feature is spec rate. It is the spectral flux of the track, where it is actually the variation in the frequency of the songs, meaning that the songs can go from slow to fast and then to slow again, and that is called the variation. So, using the features explained just now, the machine learning will use it to predict the song's mood, and then the songs will be filtered by checking if the predicted mood matches the user's selected mood. Lastly, this machine learning will produce an output of the song's mood and a list of songs predicted that matches the mood input. This is the software architecture of the system. User will authorize PulsePlay to allow the system to access their Spotify data. The system will retrieve the user's listening history, top tracks, and saved tracks to ensure personalized music recommendations. The system will then extract the audio features, then send it to the decision tree model in the job-lib file. The model will return the songs and its predicted mood. The system will then match the predicted song mood with the user's mood input. After that, the user can provide feedback, and the feedbacks will be stored in Firebase. In conclusion, PulsePlay is able to provide Spotify users with personalized and mood-tailored playlist generation using a decision tree model. The prediction is performed using the audio features of the songs. Now we will proceed with the system demonstration. Let's say there's a user named Siti and she's feeling sad, so she would like to listen to sad songs. So she went onto PulsePlay and logged in with her Spotify account. So once she is logged in, she will be brought to the permission access page. Once she agrees, she will be brought to the mood input page, where she can select from 4 different moods, which is sad, happy, energetic, and calm. She is selecting sad, and now she submitted the mood. Once the mood submission is successful, a feedback prompt will pop up. This is to get the user's current emotional well-being. The purpose of collecting this data is to track whether the playlist has helped the user to feel better. Then, Siti is currently seeing the playlist page. It takes a few seconds to get the playlist generated. These are the songs that have been predicted to match Siti's mood. There's 32 songs from her Spotify retrieved songs that are predicted to match her sad mood. Down here in the all predicted songs are all the songs that have been retrieved and its predicted mood. The system receives this list of all predicted songs, then matches it with the mood Siti had selected earlier. Next, Siti can add this playlist to her Spotify library. She can now view the playlist in her Spotify app. Now, Siti is prompted to fill in the feedback forms. The first question is to get the accuracy on whether the song suggested matches the mood she had selected. The second question is to get the accuracy on whether the song suggested matches with Siti's music preferences. Lastly, the slider is to get Siti's current emotional well-being to determine whether the playlist has helped her to feel better. And done! Siti now can go to her Spotify and enjoy the new playlists that have been added to her Spotify library. The end of the system demonstration marks the end of my presentation for PulsePlay as well. Thank you.